Alright, this is Unit 12, Day 1, Part 2, Derivatives. We'll be dealing with instantaneous velocity and average velocity, right? So, first thing that comes up on this page is our formula right here. That's going to be to find our average velocity over 2 points, right? We're given 2 points, right? We're given A in the function of A, B in the function of B. We'll be finding the velocity, the average velocity, or the slope between those 2 points, right? And our second formula is used to find the instantaneous velocity during that time, right? That's our tangent formula. That's to find the instantaneous velocity at a single point, or the instantaneous slope at that single point. This is pretty much the same concept from before, but we're applying it to distance and time. Alright, we'll start with the first problem, right? So the first problem is you're trying to find the average velocity between second 1 and second 4, right? And we're going to be dealing with that in meters using the function here, t squared minus 1, right? Our time squared subtracted by 1. So we're going to start using pretty much the same formula, y2 minus y1 over x2 minus x1. Our y2 comes from 4, right? Our function of 4 squared is 16, subtracted by 1 is 15. Minus, we'll use our 1 here, 1 squared is 1, subtracted by 1 is 0. Divided by our x2, which is our 4, subtracted by 1, be 15 over 3, which equals to 5 meters per second. We'll just go through one more problem. Our y2 minus y1 over x2 minus x1. We're going to pretty much apply the same math here. 3 minus 0 subtracted by 2 minus 1 equals 3 over 1, which equals 3 meters per second. Alright, that's to find our average velocity over 2 points. Next, we'll be given our instantaneous velocity. I'll just write down the function that's given to us again. Right, so using the formula, right, our function of t plus h would just be t plus h squared minus 1, subtracted by our function of t, which is t squared minus 1, divided by h. The limit of when the change of x is equal to 0. Right, and now we just kind of simplify, right? Be t squared plus 2th plus h squared subtracted by 1 subtracted by t squared plus 1 divided by h, which would equal, right, we just gonna simplify everything down, right, equal 2th plus h squared divided by h, and then we just cancel out the h's. And suddenly, we can plug in h for 0 without getting an undefined value, right? That'll just be t, 2t is equal to our velocity, right? And next, they're asking for the particle 1 second. So we just plug in 1 second for our time, right? So our velocity at 1 second is equal to 2 meters per second. That's our instantaneous velocity. Alright, let's continue with estimating the slope at the given point on the graph. So we'll be looking at this graph and we'll be estimating the slopes at a certain x value, right? So let's start with our first one. X equals negative 8, right? That'll be x equals negative 8 would be right here. Right? And we're looking, is the slope at that singular point positive, negative, or 0? So not the point, but is the slope positive, negative, or 0? Right? And the way to figure that out is we're going to look at the trend from before and after, right? We'll see that it's slightly going up before and after, right? So that means we can relatively assume that at that singular point, the slope will be positive. And another way to imagine this is if we move our point slightly behind or slightly forward, is our slope going to be positive or negative, right? And if we move it just that tiny bit, our slope will be positive, right? And then let's look at x equals -3. All right, we're going to right here. And then we can kind of apply the same knowledge. Is if we move it tiny bit left, our slope's positive. But if we move it tiny bit right, our slope's negative. So we can relatively assume that at this peak, our slope will be 0. Right? At that peak point, our slope is 0. And then we'll look at x equals 0. And we can kind of, if we move it just a tiny bit, our slope will be negative. You can see the slope going down. And then we can look at x equals 2. Right? And it's also going down. Let's look at x equals 4. You can see it's going up. And we can look at x equals 7. And we can see it's going up very slightly. Perfect. And then we have to arrange those slopes from smallest to largest, right? This is where it gets a little bit confusing, right? So we're going to start with our smallest slopes, right? That's all our negative slopes, right? So that would be our x equals 0 and x equals 2, right? So let's start with x equals 0, right? To find how steep a slope is, to find how small or large a slope is, we have to look at how steep it becomes, right? The steeper it is, the larger the number gets. Right, so you can see at x equals 0, right, it's relatively tame, right? It's not that steep. But if we look at x equals 2, you can see that before and after it's much steeper than at x equals 0. And if it's much steeper, that means the slope value will be more negative, right? It will be a larger negative value. So we're gonna write d and then c. And then our next value is going to be our 0 because it's between negative and positive. So we automatically know that's there. And then let's look at A, E, and F. Right, we'll start with -8, right? It's a relatively, it's not very steep, right? Let's look at x equals negative. Let's look at E, x equals 4, right? And it's steeper than A. And let's look at the F, right? You could tell that F, if you move it a little bit left and a little bit right, you can tell that F is less steep than the other two, right? So we're going to write F here, and then the one next is going to be x equals -8. It's not very steep. And then the steepest one would be E at x equals 4. And that's how we arrange those slopes from smallest to largest. Alright, this is where it gets a little bit more complicated. We're using both skills that we just learned to read a graph and find the average rate of change, right? So we're going to watch this graph shows the number of people in a store from 10 a.m. to 6 p.m., right? So we'll just number. Here's the first thing I'd like to do is number our x values, right? Instead of saying 10 a.m., 11 a.m., we're going to say 0, 1, 2, 3, 4, 5, 6, 7, and 8. Right, and then what is the average rate of change in the store from 11 a.m. to 12 a.m., right? It's not our instantaneous. It's the average between 11 a.m., which is our one value, and 12 p.m., which is our second value, right? So we're just going to use the kind of y2 minus y1 over x2 minus x1. We'll say, we're going to say, well, our two coordinates is 1, 5, 2, and 10. And then we just use our slope formula. And we get 5 people per hour. Between 11 a.m. and 12 p.m., there's an average of 5 people per hour. Right, that is what we're saying. And we basically apply the same thing from here, right? 2 p.m. and 4 p.m., right? We have 4:15, 2 p.m. and 4 p.m. We have 6 and 4. We'll just do 4 minus 15 over 6 minus 4, right? And then we'll have negative 11 over 2 people per hour, right? We're thinking, how do we have negative people per hour? Well, that just means our number of people, right, will be going down. Our negative 11 over 2 is not a value, but it's a slope. It's a rate of change, right? We're decreasing by 11 over 2 people per hour between 2 p.m. and 4 p.m. Okay, now we'll estimate the instantaneous rate of change between 2 or at 2 p.m., right? So our way of doing this is to take the average number of people between, right? So we'll look at 2 p.m. We'll take the average amount of people between 1 p.m. and 2 p.m. and we'll take the average amount of people between 2 p.m. and 3 p.m. and then we'll average those two values out. So let's first find the average of people between 1 p.m. and 2 p.m., right? We'll write down our 2 points. We'll write down 322, right? And then we'll write down 415, and we'll just write down our third point, 5. And then we'll just subtract the first two values out. We have 15 subtracted by 22 over 4 minus 3, right? And then we're going to write, and then it'll be negative 7. So that's negative 7 people per hour as our slope before, the slope 1 before our 2 p.m. value. And then we'll do it for 5 minus 15 over 5 minus 4 equals negative 10 people per hour. That is our time. That is our hour after our 2 p.m. And then we'll find the average between those two numbers, right? Negative 10 plus negative 7 divided by 2. That's how we find the average. We get negative 17 over 2, right? So that will be our instantaneous rate of change. Our estimated, obviously, is negative 17 over 2 people per hour, right? And then an approximate what time during the day is the instantaneous rate of change of people with respect to time in the store the greatest, right? So that's when is our slope going to be estimated as the greatest. And our biggest rise in time is this slope right here, right? And because people come and go throughout the hour and it's described as a straight line, we're just going to estimate it as in the middle of those two data points, right? That'll be between 12 and 1. So we'll say 12:30 p.m., right? It's between those two data points with the largest difference, right? And then what rate of change is going to be the smallest, right? So the most drastic steep to the negative side. You can see it's between these two dates, right? So that's between 2 and 3, so that'll be 2:30 p.m., right? So it's fairly easy to explain those two. It's where the slope's going to be the largest, and it's where the slope's going to be the smallest. Instantaneous rate of change is just the average between the hour before and the hour after. And to find the average rate of change, it's just using y2 minus y1 over x2 minus x1 to determine how many people per hour at that given data time.